We're going to talk about graphing logs. Shh. Let's get started. We're going to start out by looking at a few things. So let's listen carefully. I'm going to graph a couple of things first. What you see on the very first column of x's and y's, look, this is x and this is y equals 4 to the x. Because this is the exponential version. Just to go to show you that these are really inverses, look at the other graph. Okay? Look what we have here. Look at this one and this one. You have the log base 4 of x, and you have x. Inverses directly reciprocal of each other. So you can take the x's and y's in the first part, you swap them to get the logarithm graph. Okay, some people actually graph the exponential part because they think about the exponential better, and they just take the x's and y's and they just swap them and they graph them that way, and you got the logarithm graph, which is fine. So I've written it up here. In the red box, you see b, 1 over b, 1, and b. Those are going to be your x coordinates for all parent functions.
How do you know what b is?
B is the base of your log. In this case, what's b?
4.
It's 4. If that had been log base 2, then we would have 1/2, 1, and 2.
Wait, what did you say?
In the red box, those are pretty much your x coordinates for all parent functions. And it's based on whatever the logarithm base is. In this case, it's 4. But if it had been 2, we would have 1/2, 1, and 2.
Based on the base?
It is based on the base of the log. That's right. Yes, ma'am.
Based on the base.
Brittany. I'm going to go ahead and write down. Look here. Look on the screen. Look at the board. The screen. 1.7, negative 1.75, negative 1, 2, negative 1, 0, and 1. Where did I get those x coordinates? Somebody tell me.
By plugging
The 2. You subtract the 2.
Very, very good. What happens in terms of x plus 2?
Oh.
That's unfortunate.
What did my graph do?
Shifted.
Which way?
to left.
Left 2. So what do we do to all my x coordinates?
Subtract.
I subtracted 2. And so that's where you're going to get the negative 1.75, negative 1, and 2. I subtracted, basically I said 1/4 minus 2, 1 minus 2, and 4 minus 2. The next step would be to graph it. Can you tell me where does the red line come from?
It's the vertical asymptote.
Where did I get it?
The negative or the positive 2 plus 2.
I knew that my graph went 2 to the left. The original asymptote of all logarithm graphs is what? 0. Right. It's x equals 0. Make sure you write that down. Because y equals 0 is a totally different idea. Okay, so we're going to ahead and graph that. And you see the graph here.
So logarithms, the asymptote is going to be on the horizontal. Like up and down, I mean.
Right. It's a vertical line.
And then, what are the ones where they're...
Horizontal line. That's the exponentials. Let's talk a little more about this. What's the domain of this?
All real numbers greater than 2?
It's all numbers greater than negative 2. Not equal to, because that asymptote prevents it from being equal. It's just, you could write it as, so in this case the domain would be x is greater than negative 2. What about the range?
X is greater than negative 2. All real numbers. Yeah.
Why is it all real numbers?
You can use any number.
It goes up and down forever. Never going to stop. How does that relate to the exponential graph? Shh.
It's opposite.
It's opposite. If we can switch our x's and y's,
Range is always going to be all real numbers.
write that down. Very good.
Logs.
For logs, listen. For logs, the range will always be all real numbers. The domain will not be. For exponentials, the domain is always all real numbers. What is your domain kind of based off of?
The asymptote.
The asymptote. Now be careful. I could give a reflection here It's not always greater than. It could be less than, too. If you had a reflection, then the log would flip over and go the other direction. Sir? If I had negative log base 4 of x plus 2, then it would be this direction. No. Probably won't do a whole lot of those, but it's possible. Okay? Let's go on to the next section. I want you to try graphing one by yourself. Shh. Here we go. Here we go. Listen, here's what I want you to write down. When you graph these, I want those 3 points. I would like to see, listen carefully, I would like to see the x-intercept. At this stage of the game, you might not be able to find it without doing some calculator work. If that's the case, then I'm really not so concerned about it right now. But I absolutely need to see these 3 points that we graphed, translate those from the parent function. I need to see the vertical asymptote. On the quiz from last week, the reality check, those of you that drew the asymptote in did a good job of graphing your exponentials. But those of you that left the asymptote off, your graph's all down and you didn't know where you were supposed to stop or keep going or what. Draw the asymptote in. Not optional. So, let me go over this one more time, just to recap. First thing we did was we graphed the parent function, the points. That was 1 or 1/4, -1, 1, 0, 4, 1. The second thing we did was we went ahead, we looked at what happened in our graph. We saw that we had here, we had to add 2 to the x. And here, we went ahead and we added 4 to the y coordinates. Okay? And I went ahead and created those down at the bottom here. So you have 2.25, comma 3, 3, comma 4, and 6, comma 5. We talked about the vertical asymptote. The vertical asymptote comes from whatever happens inside here. If nothing is added or subtracted to x, what does your vertical asymptote remain at?
1, 0.
0. Originally, the vertical asymptote is x equals 0. I need you to be aware. When I ask you for a vertical or a horizontal asymptote, you better give me an equation of a line. X equals 2 in this case. If it was an exponential function, it would be y equals 0 or whatever. Horizontal asymptotes always take the form of y equals. I went ahead and graphed it. I made sure to graph the asymptote. I made sure not to break that asymptote. The domain, because my asymptote is positive 2, and my graph is on the right side, the domain is going to be x is greater than 2. The range, of course, is all real numbers here. Any questions on how to graph these? There's a lot of parts to this. Look at the x. Where does it start? That's your vertical asymptote.
Where x starts.
It starts at the... Where's the vertical asymptote?
2.
At 2. So the graph exists on the bigger side, right? So it's at 2 and bigger. That's the domain.
Why don't we do the exponential?
What do you mean?
Graph the exponential instead of the log.
Because we're talking about logs right now. We have already done the exponential stuff. That was last week.
So
We'll come back to it.
When you come up with the coordinates
Quiet.
that you're going to plug in, do you put them in the y or the x for logs?
It depends on what you come up with. For us, for that parent function, for this part right here, we just remember that the y coordinates are always -1, 0, 1.
Oh.
The x coordinates are always 1 over b, 1 and b, and that's where I start from, and I change it from there. Any questions on any of this stuff? Let's try one more. We got enough time for one more. Now that we've got our pieces, we've got our original, we've got our parent,
Transformed.
and we've got our new stuff. What's the vertical asymptote? It's positive 1, absolutely. Let's go ahead and plot my new points. So we're going to have 1.2 for x, and then negative 2. So that's something about here. And then we're going to have 2 negative 3, so 1, 2, negative 3. And then we have 6, negative 4, which are off the charts. 1, 2, 3, 4, 5, 6. So I'll just estimate it's way down there somewhere. Shh. Look at the graph. Notice this graph is upside down. Your base was a fraction, so that inverse, it flipped it over the x-axis. Be careful about that. Anytime that you have a fractional base, it's like reflecting it over the x-axis. It's going to be upside down. Be aware of that.
So instead of a decrease, it would be growth.
And that's decay. That's logarithmic decay. It drops really, really fast.
Is that because the
It slows down.
is
Instead it would
1/5?
be growth, right?
It, naturally, as growth goes up, but now it's decay.
Is that because the base is 1/5?
Yes. Your homework tonight is to finish the odd problems. Okay? Technically speaking, tomorrow, those of you that have had the paper, tomorrow the entire odd sections are due. Those of you that got the paper today,
1 through 39?
Wednesday.